Hello, so picking up where we left off, we were talking about this hockey data set example, and we're just now getting into kind of the new stuff, which is inference. And so let's first talk about a test to see whether distance is associated with whether or not a shot goes into the goal. As you might guess from the table of output, nothing's really that different. We're just going to grab the p-value from the row with distance, and that's our p-value for our test for whether distance is associated with whether or not a shot goes into the goal. That's one huge nice thing about R, or about really most computer software programs, is that they're going to give you output that looks pretty similar for different types of tests and stuff. So let's go ahead and go through the steps of the test. Let's write the null hypothesis in notation. So that's just going to be that the slope is equal to 0. And the alternative is just going to be that the slope is something different from 0. So this is the same exact null and alternative that we had for simple linear regression. The test statistic is going to be our point estimate for the slope minus the null value divided by the standard error. And so we could grab all of that from our summary table of output. It actually gives us the test statistic as well. It should be minus 7.25, but if you wanted to, you could check to make sure that that the algebra checks out. So if you did this calculation, you should wind up with what's given in the table of minus 7.25. And so you'll notice one thing that's different is that now on the table, we're working with a z-value and a z-distribution instead of a t-value and a t-distribution. And so why is that for logistic regression? We're not really going to get into it. We're just going to note that that's from stat theory. And so again, this is supposed to be like applied regression analysis or applied modeling. And so we're really, we spent like a really brief amount of time talking about some theory stuff in simple linear regression, but we're not really going to get into it here. And so you'll just kind of have to go with it. And so then the final part is we could write our conclusion. And since our p-value is so small, we could say something like, all right, there's strong evidence that distance to the goal and whether or not a shot goes into the goal are associated. We could give our test stat, and we could just say our p-value is so small, I'm going to say less than 0.001. Okay, so like nothing like super groundbreaking here. I'm not even really into hockey, but even if you asked me if distance to the goal and whether or not the shot goes in are going to be associated, I would say yes, even without the statistical test. I think that's somewhat obvious that the farther away you are from the goal, the less likely the shot's going to go in. And so we could also figure out a 95% confidence interval for the odds multiplier. This might be a little bit more useful since it's not really obvious to me what that odds multiplier is going to be. And so we're going to do this in a couple of steps. First, we're just going to find an interval for the slope on the Logit scale. So we're just going to find an interval for beta 1. And remember, beta 1, the linear form is just on the Logit scale. And so to figure out this interval, we're just going to take our estimated slope we're going to add and subtract. Now since we're working with z instead of t, we're going to add and subtract a z star and multiply that by the standard error. So the z star we could get, remember we were using qt to find the t star value. For z star, the function's q norm. And if I want 95%, that means I want to find this q norm 0.975 from similar logic to when we did this with the t distribution. And so if you do that, you might actually just remember from stat 113 that the z star for a 95% confidence interval is just 1.96. And then you could grab the standard error from the table and wind up with an interval from negative 0.034665 to negative 0.01991. Okay, so what exactly is that? That is an interval for the slope on the Logit scale. And so it's not super useful because the Logit scale is like even more confusing than just interpreting it via odds. And so what we want to do is we want to do something super similar to what we did with the slope when we interpreted it. And more specifically, we want to back transform the bounds of the interval. And so if I do e to the negative 0.034665 and then e to the negative 0.01991, my back transformed interval is 0.9659 to 0.9803. And so this is at least a little bit more interpretable, though with odds, I still kind of tend to fumble a little bit, and it's not as intuitive as the interpretations were in linear regression. But we could at least say with this that we are 95% confident that for a 1 foot increase in distance, so far it's simple or similar to linear regression. The odds of a shot going into the goal. So what happens to those odds if we increase the distance by 1 foot? Well, they change between 0.9659 fold and 0.9803 fold. Again, this is like, I don't know, it's like a little bit unsatisfying because we've done so